Hi guys, welcome back. Today we are going to talk about the mole. The mole is an SI unit. If you remember back from chapter 2, we talked about some of the fundamental units. The mole was probably the one that you were not familiar with. The mole is just another way that we have to measure matter. And if you think about the ways that we measure matter, there's lots of different ways that we can do it. We can do it in terms of mass, volume, length. Sometimes, and with certain things, you might buy things by the yard or by the foot. But there's lots of different ways that we measure matter. Thinking about groceries is a great way to think about how we all measure matter and how we like to quantify matter. And sometimes volume is better. You buy gallons of milk or gallons of gasoline. Or pints of sour cream or something like that. Other times mass is better. You might buy so and so many pounds of hamburger, or you might buy I don't know, like a 5-pound bag of sugar or something like that. And other times amount is better. Amount is counting. Like you might go and buy 5 apples, or you might buy 3 limes, or sometimes we group things when we count them, right? We might buy a dozen eggs. Again, no one says go out and buy 24 eggs. They say go out and buy 2 dozen eggs. Or they might be in like a 24 pack, a case of soda. You might go out and buy like 2 cases of Mountain Dew if you have a lot of studying to do. Or you have a yellow dye number 5 addiction or something. And grouping like this helps us to count. Think about how you would count pennies in a jar. If you're counting by ones, you might be like 1, 2, 3. You get all the way up to like 942, and then something distracting happens. A dog goes by on a unicycle, or somebody goes by with a really good-looking sandwich, and all of a sudden you forget what's happening, and you lose count. And then you have to start over again. Grouping allows us to, if we lose count, not to have to go all the way back. You don't have to go all the way back to the start. You just, in chutes and ladders, you just go down a little bit, right? But not all the way back to the beginning. So when we're counting, sometimes we like to collect or organize items into a group. It might be a stack of 10, it might be a stack of 100. It depends on how many of the thing we're trying to count. Chemists do this as well. They like to group atoms, molecules, other very small particles into little groups, and because there's a whole lot of atoms and molecules in different samples, our collection is pretty large. Our collection is in something called the mole, not the furry little burrowing, nearly blind creature that you might be thinking of that tears up your yard, but rather a mole is a collection of what we call representative particles, and we'll talk about what those are in a second. A mole is 6.024 times 10 to the 23rd representative particles. It's often called Avogadro's number. If you remember from the video we watched the other day, Avagadro is very well known for some of his gas laws and for work in determining that oxygen is actually a diatomic molecule, but we'll talk more about that in future chapters. The mole, like we said, is 6.024 times 10 to the 23rd representative particle. And a representative particle can really be any smallest chunk of matter. It depends on what that type of matter is. And there's 4 main categories. We have molecular compounds, like water. We have, and they're all bonded covalently. We have ionic compounds, like table salt, which are held together with ionic bonds. We have ions themselves. You can have like a collection of ions, although this one is very rarely used. And then, of course, elements, pure elements, the smallest particle is the atom. For any of those, you have a smallest particle. Ionic compounds, the smallest possible piece is called a formula unit. For molecular compounds, the smallest piece is called a molecule. Formula unit is kind of the molecule of ionic compounds. And then for elements, of course, the smallest possible unit is the atom. The smallest piece you can have of one element and still call it that element is 1 atom of that substance. So that's a representative particle. Again, the smallest possible piece of something that you can have and still call it that something. The smallest possible piece of water is 1 molecule of water. The smallest possible piece of table salt is 1 formula unit of table salt. And the reason that we spend so much time with amount is because when we do chemical reactions react in terms of amount. They react in terms of atoms and molecules. So and so many atoms of copper are needed to react with so and so many molecules of water, or something like that. We don't work in terms of grams and milliliters. And anytime we take measurements in grams or milliliters back at the lab, we'll have to convert them into amount. Okay? It would be like trying to determine how many people got onto the football field by mass. Like, well, you're only allowed 10,000 pounds out on the football field. Well, depending on the size of the player, you might have, 50 players. 10,000 pounds is a lot of pounds. I may have overstretched there. 2,000 pounds, let's say. You're allowed 1 ton of humanity out there. You may have like 4 guys, or you may have 20 guys out there. It just depends on the size of the guy. Football teams act in terms of whole individuals, right? Like the quarterback, the running back, the lineman, they're all different sizes and shapes, but they all act individually. The same thing kind of works in a chemical reaction. You can't treat all these compounds the same using mass or volume, like kind of lump them all into the same category, because different molecules and atoms are different sizes. You would call an elephant and a squirrel individual creatures, right? You wouldn't say the elephant is worth more because it weighs more or takes up more volume. An elephant is an individual. It has 1 brain. It has 1 trunk. I'm getting away from the point here. And so is the squirrel, right? This slide was supposed to get deleted. Avogadro's number, or the number of moles, will act as a conversion unit for us, a way to get between moles and number of atoms, number of molecules, basically a way to get to number of representative particles. So let's go ahead and do a quick little calculation here. How many atoms are in 1 mole of silver? Well, right off the bat, you could probably answer, well, it's a mole, so it should have 6.02 times 10 to the 23rd atoms. You could also do this via dimensional analysis. 1 mole of silver. Everyone right now just got a weird tingly feeling in the back of their neck, that feeling of dread. And our conversion factor is going to be Avogadro's number. We are trying to go from moles to atoms. There are 6.02 times 10 to the 23rd atoms, or 6.024 times 10 to the 23rd atoms of silver in 1 mole of silver. And so moles of silver cancel out, and we are left with 6.024 times 10 to the 23rd atoms of silver. Now, that seemed pretty easy. Let's try another one. How many molecules are in 5.5 moles of C3H8, or propane, and propane accessories, as C3H8 is more commonly called? We're going to set this up exactly the same way. Our starting point is 5.5 moles of propane. And I'm going to convert moles of propane into molecules. C3H8 is a molecular compound. I cannot use atoms. I have to use molecules. So 6.02 times 10 to the 23rd. Notice I'm, again, putting it on top. 6.024 times 10 to the 23rd. Molecules. Man, that is the worst scrawl I've ever seen. Sorry about that. Per mole of propane. And if I were to solve right now, I would get number of molecules. So let's go ahead and do that. I'm just going to write my answer down below here. 5.5 times 6.024 times 10 to the 23rd. I'm going to pause it while I punch this into a calculator. All right, and our answer is 3.3 times 10 to the 24th molecules. You can see the moles canceled nicely, and we were left in units of molecules. All right, and the second part of the question asks about atoms. Now, You will have questions like this on quizzes and tests where they give you a compound, they give you something that has more than one atom strung together, and ask you about how many atoms. Well, Avogadro's number is good for the number of representative particles in a particular substance. The representative particle for C3H8, like we said, is the molecule. To get to atoms, I have to do one more conversion. I'm going to look at C3H8 and how many atoms are in a molecule of C3H8. Well, there's 3 carbons, there are 8 hydrogens, and so that is going to give us 11 total atoms per one molecule. Again, this is for C3H8, this is for propane. This will be different for something like CO2 or for H2O. And all we're going to do is do one more calculation. So take our current answer. You know what, I'm just going to replug the whole thing in. 5.5 times 6.024 times 10 to the 23rd times 11, and I get 3.6 2 sig figs times 10 to the 25th atoms. So again, fairly simple, straightforward calculation there. Let's do one more, and then we will call it a set of notes. Last conversion factor here. How many moles are in 7.82 times 10 to the 24th molecules of P3O7? And this one we're working the opposite direction. 7.82 times 10 to the 24th molecules. And I am going to put in my 6.024 on the bottom this time. And the reason for that is I want the molecules to cancel. The P3O7 is a molecular compound, so the representative particle is going to be molecules, and that's per 1 mole of that substance. We go ahead and calculate that out. 7.82 times 10 to the 24th divided by 6.024 times 10 to the 23rd, and I get 12.98. We'll just go ahead and make that 13.03 sig figs, and my final answer, moles. All right, and that is converting using Avogadro's number. For the next set of notes, we will talk about molar mass, and I will see you then. Thanks for watching.